Hello! In this video we present our demo named Understanding the Security Challenges of Oblivious Cloud Storage with Asynchronous Accesses developed at UCSB. Our goal is to highlight the important security features of Oblivious storage systems even in the presence of a powerful adversary. Outsourcing private data has become increasingly popular and these services provide useful features, but what about security concerns? Many systems use encryption as a tool to secure confidentiality. The question that we need to ask is whether encryption is enough or not. Unfortunately, the answer to this question is negative. Access pattern leaks sensitive information. Let's try to make it clear what access pattern does mean. Assume Alice sends a read request that accesses a data block. Later, the same data block is also accessed by Bob. Our attacker sits in the cloud and is able to see two requests accessing the same block. If the data block is for a certain drug, the attacker might understand that Alice and Bob have the same medical condition. To hide access pattern, we would like to achieve oblivious access. Basically, we are looking for a way to translate each logical access to a sequence of random-looking accesses. Oblivious RAM ensures oblivious access. Many ORAM constructions support only single client scenarios. However, in this demo we consider multi-client ORAMs and try to attack two recent schemes, ObliviStore and TaoStore. Both of them consider a proxy model where the ORAM client mediates the client requests. Let's take a look at the threat model which describes the powers of an attacker. The threat model assumes an honest but curious adversary who can see the physical storage and the network communication. She controls the asynchronous links where she can delay the message arbitrarily long. Additionally, an adversary can schedule access operation adaptively and learn the timing of a response. To win the game, the participants need to develop an attack. As a hint, we capture the attack developed against ObliviStore. This is just one way to develop an attack. It's time to develop your own attack against ObliviStore and TaoStore using our new game, Guess the Access. Now we are going to explain our game, Guess the Access. This game will help participants better understand the timing attack against ObliviStore and TaoStore. For this, we ask the participants acting as attacker to design an attack trying to reveal any information about the encrypted client queries. Now we are going through our gameplay to explain how a participant interacts with the system. A participant selects which protocol to attack, in our case either TaoStore or ObliviStore, and sets the protocol parameters, for example the write-back threshold for TaoStore. Let's take an example. We choose to attack TaoStore. We are going to set the dataset size to 4 unique data items, and the number of client queries to 6. These queries are generated to uniformly access these 4 data items. For TaoStore, we are going to configure the write-back threshold to 3, which means that the proxy has to write back the local content to the storage server every 3 path fetch. Now we are ready to generate the workload and design the attack. As we can see in the game interface, the attacker can edit all the information we mentioned earlier in the threat model. In the lower part of the screen, the attacker can inject queries. The attacker defines whether the request is read or write. The key of the data object accessed in the request, as we can see, we have 4 of them, the start time, and if the request should be delayed or not. The attacker can insert as many requests as she wants, then clicks start. Our implementation takes these inputs and emulates selected protocol, either TaoStore or ObliviStore. The demo allows the participant to monitor all network communication. However, monitoring many simultaneous messages is hard given that the operations are emulated very fast and the logs are not easy to interpret. Therefore, we developed a timeline interface to help the attacker trace the requests and the responses. The attacker can hide different types of messages. Also, the attacker can replay the log step by step, moving forward or backward. By observing the message exchange, the participant is required to submit her guesses about the hidden queries. The score is calculated based on how many queries are correctly guessed. After filling all the guesses, the participants click submit and get the score. That's all folks, thanks for watching.